So here we're going to determine the domain and range of each relation or function. All right, this is our familiar slanted line, and we're trying to figure out what values of x are we allowed to plug into this formula. That's the domain. So if you can't tell from just looking at the graph, like what x's are allowed, then you might think about it as a machine for just a moment. The machine has inputs on the left, outputs on the right. And when we're considering the domain and range, we want to figure out what are we allowed to put into the left side of this and not have a problem. The rule f of x equals x simply says that whatever you put in on the left comes out on the right. So if you put in a 1 on the left, you get out a 1. If you put in a -3 on the left, you get out -3. If you put in a 8.2 on the left, you get out 8.2. Is there any number, any real number that we can't plug into this formula? And the answer is no. This operation can be done on any number. So what we want to say then is we want to say what the domain is in words or symbols. We can say it a number of ways. One way to say it is just simply all real numbers or all reals. We can also use the symbol for the real numbers, big R. We may wish to use algebraic notation. We can put in any x that is between -infinity and infinity, so anything is allowed. Or we could put it into interval notation. So it would go from -infinity to infinity. The parentheses means you can't actually plug in infinity though because they're not real numbers. All right, so let's try the next one. We'll change our function here to f of x equals 0. When we do that, then no matter what we put in, we get 0 out. But are there any restrictions on what we can throw into the left side of this machine? The answer is no. So our domain is again going to be all reals. And we could state that as big R, or we can put it into algebraic notation or interval notation. All of these four things say the same thing. All right, how about f of x equals x squared? We're going to multiply each input by itself. So 1 times 1 makes 1. -3 times -3 will actually take away the negative. It'll become +9. And 8.2 times itself, 67.24. Okay. I can't think of any number that I can't plug into that. I could square any real number, but just by multiplying it by itself. So once again, our domain, our domain is all real numbers. And here for negative x squared plus 4, it's going to be the same. What about for 1 over x, though? Is there a number that we can't plug in? It turns out you can plug in almost anything. But there is one number that we can't plug in. We could try it on calculator. We could try 1, negative 1, and 0. Now you do 1 divided by 1, you get 1. 1 divided by negative 1 makes negative 1. But 1 divided by 0, you try it on calculator, it's going to tell you undefined. There's no answer to that. And whenever a function returns a value of undefined, that means that that x input is not part of the domain. All right, so how can we write that? Well, one easy way to say it would be all reals except 0. It's a casual way of writing it, but that works. We could also write it in algebraic notation. Now it's a little tricky. We'd have to say x is less than 0 or x is greater than 0. That'd be one way of saying it. So you can enter negatives or positives, but not 0. Now putting this into interval notation is a little tricky. We want to go from negative infinity to 0, but not include 0, so we want to use parentheses there. And we also want to go from 0 to infinity, but still don't include 0, so we don't use a bracket or anything. And the last thing that we'll do is use a notation which is a U between them. The U stands for union, which means to merge two intervals together into one domain. Okay, this brings us to the function f of x equals the absolute value of x. An absolute value function takes away any negatives in the x and just makes it positive. So for example, if we were to throw in negative 2, 0, and 2 here, then the outputs would be negative 2 becomes positive 2 because it's going to take a negative and make it positive. 0 has no sign, so it'll just stay itself. 2 is already positive, so the output will be positive 2. The idea being it takes any number and just gives us the positive value of itself. So is there any number that we can't throw into that machine? The answer is no. We can throw in anything. So the domain is all real numbers. All right, for this next one, x equals 2, it's worth noting that this is not a function. So I can't really use the machine analogy here. Instead, I'll just list the only x value that is possible for this relation. It's just a single number. For a single number, we would put it in braces. That's how we listed single discrete numbers as domains in the past. And finally, for the function f of x equals x cubed, the domain is all real numbers.